Good, thank you. Someone's alive out there. Neil Horrocks is my name. I'm from the University of Queensland. I run a research centre, a new research centre. We're just coming out of the ground now. We're just starting to do some exciting things, but our focus is on networks and the value of data for networks. We're talking to networks across the country, so I know that this is important to networks. We've spent a lot of time with Josh and his team and networks throughout the NEM, and everyone has a view of where this is going, so I think it's quite topical. One of the projects we're running right now is in collaboration with Energy Queensland and the Queensland Government and our technology partners Redback Technologies and Microsoft. We also have a community partner in Springfield City Group. So between us, we're really starting to try and get a sense of what's happening on networks. So we are rolling out quite a large network of IoT sensors on the edge of the grid in network neighbourhoods, you know, on individual feeders out front of houses, on not behind the meter, but on the network, so we can start to bring the data back in near real time and get a sense of the physics that are at play on the network. It's really, really helpful when you're running a research centre to have access to industry experts that understand their topic, but it's also important to bring in researchers who have some new expertise. So our research centre is incorporating power engineers who've spent a bit of time now in the grid of the future, understanding the impacts of consumer technology and energy technology and how that's going to impact networks moving forward. We're also bringing in data scientists who have expertise around platforms and platform science and around data wrangling and around data security, which was mentioned earlier, a big issue for us, and around analytics, the AI and the machine learning that's going to drive the decisions that Josh talks about. And importantly, we're also bringing in researchers from the interaction design space. So these are the sense makers. These are the people who take the insights from the data and turn it into valuable information that people can interpret and use. So between us, that collaboration we think is going to be a really, really good start for us to begin to make a difference with what's going on in the network. And these projects are challenging. It's stated that as many as 85% of these data projects fall over, and they fall over for a lot of reasons. One of them is, people make the mistake of trying to bolt these data projects onto existing ICT infrastructure. And frankly, a lot of that infrastructure is just not capable of doing some of the things that it needs to do. Some of the other issues are the risks that companies feel around the data governance, the data security and the management of these sort of projects. And I think the other thing is the skills. There is a whole lot of new skills, as I've just talked about, that are needed to make these things work. So I think the first point I want to make is collaboration is important for networks as they move forward so that we can get the most out of this. And I think the other thing that's really, really important, and I heard questions previously today, and in fact, right through this session, what data should we be collecting? Well, I think the better way to come at that question is by saying something that Rose McGowan said from QCOS to me at morning tea time. What questions do we want to answer? Because unless you know what questions that you want to answer, you're just building systems for the sake of building systems or gathering data for the sake of gathering data, and in the end, someone's got to pay for that. So the project that we're doing in Queensland at the moment with Energy Queensland specifically right now is focused on safety. So we're collecting power data, which is different from energy data. Power data is about voltage and current and power factor and impedance. And with that data collected in near real time, we can see unusual and irregular flows in and out of households, and we can see unusual conditions, and we can use that data to do things like detect broken neutrals on households, which is a cause, when it does happen, rarely, but when it does happen, a cause of electrocution in homes. So we can monitor and track that by looking at currents flowing in and out and looking at changes in impedance. Having that data also allows us to do things like, or we hope it will allow us to do things like identify feeders down in neighbourhoods and maybe dispatch emergency services so that we don't have the sort of accidents that we've seen recently. It'll enable networks to provide much better security of supply for life support customers. Being able to see what's happening at a specific neighbourhood level and at a household level is really, really important for those sorts of customers. And we think it could also have the ability to provide visibility for networks and consumers when they're recovering from storm events or from major catastrophes on the network. So we think this data at that level from a safety and a safeguarding point of view has some real strong benefits for consumers. Moving past that project to the real other opportunities that I think are out there for data, and it's still early days in this space, but clearly the data can bring really significant operational efficiencies. The ability to be able to balance a network in real time and shift load around talks to the opportunity of getting better value for your network and using the existing network without augmenting. The ability to design better networks when you know how they're operating at a neighbourhood level and reduce the amount of augmentation or target your augmentation becomes really important, as well as being able to do preemptive maintenance and get better asset life through the data that you're dragging in is important. We then look at how customers interact with our networks and how that data might be valuable to them. And we've talked a lot about how customers are investing in energy technology, but with the network data, the networks will be in a position to be able to advise customers the right technology to suit them given the context of where they sit in the network. And that data will also be able to train that technology to operate for the benefit of the customer and maximise the return that the customer gets. More targeted rewards for demand response is another thing that the technology allows. And the ability to accommodate more solar, more batteries, all of these things are an opportunity that exists with the data. And then, of course, the other thing about the data in response to the customers is it enables networks to provide the seamless service that we're all coming to expect from all our service providers. You know, the ability for a network to know that you're out of power before you have to ring them and ask them why you're out of power is something in 2020 probably we would all expect, but we're still a long way from being able to get there. Automatically triggered service level payments when things go wrong through processes is something else that probably should happen. Being able to move in and out of rental properties and getting a text to say that your power's just gone on or we've just closed your account are things that should happen seamlessly, but they just don't happen right now. The other thing is when networks communicate with customers, you know, knowing where that customer's connected on the network's important so that you can contextually talk to people about what's happening to their supply. But if you think about 100 years of installing power to homes, that data, some of it, is quite old and unreliable, but we can distill that information from network data when we start to bring it forward. So data for networks, I think, is really, really important. I think de-identified, it's great for policymakers, as we've heard. It's also great for governments in community infrastructure planning and health and social outcomes. But one of the things that's becoming clear to us as we look forward is the technology that will allow this, and we've heard it a couple of times over the last few days, is continually evolving. And every time it evolves, it brings new benefits for the users of that technology, new capability. And this technology, new technology, you know, probably is not going to last us much more than 10 or 15 years. I doubt any of us have a mobile phone that's 10 years old. And so investment in this new technology needs to be considered, and we need to be careful about how much we spend. It needs to be targeted. We need to take advantage of some of the low-cost opportunities that exist with cloud computing and low-cost IoT sensors, and just focus on trying to get the most value for the data that we can. I think I'll finish it there and we'll pass on to the next speaker or the questions. Thank you.